One of the quintessential experiences of camping is a campfire, that warm and comfortable place where you can roast s'mores and tell spooky ghost stories that make everyone's skin crawl. However, there are times where these happy family moments turn into a disaster that is so large it can chart thousands of square miles of land, destroy livelihoods, and even contribute to climate change. These disasters are known as wildfires. This is the fourth installment in a series where I look at extreme weather events that have impacted the world in recent years and how they might change going forward. If you haven't checked out the previous installments in the series, I would highly recommend checking those out. And as always, I'd appreciate if you would like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so how do wildfires start? Well, one can start in a large variety of different ways. On average, about 90% of wildfires are started by humans in some way or another, whether it be a prescribed burn going wrong, someone throwing a cigarette butt out the window, a campfire being left unattended, or power lines being toppled by high winds. The remaining 10% of wildfires tend to be started by lightning, which makes sense as the extreme heat lightning generates can make it very easy for vegetation to ignite. Regardless of the cause, once sparks find a dry piece of vegetation, they can start burning. And if there's something fanning the flames, such as wind, it can allow them to spread to new areas. This process can continue unimpeded until the fire reaches a geographic barrier such as a river, vegetation that's harder to burn, or significant precipitation in either rain or snow falls. It should come as no surprise then that these fires can burn for months without human intervention. If a wildfire is large enough and produces enough smoke, they can produce their own wind patterns in what is known as a firestorm, and these fires can be especially hazardous to anyone near them. So, where do wildfires happen? Well, given that all that is needed for a fire to start is hot weather and dry fuel, really anywhere that has 1. Been hotter or drier than usual, and 2. Has fuel to burn. Some places, such as the western US and the Canadian boreal forests, are particularly severe hotspots for wildfires due to their dry climates and plentiful fuel in general. But if there has been a place that has been a prolonged drought or heat wave, they are susceptible as well. For example, Florida, a US state typically known for its hot and humid weather, can occasionally experience droughts that result in thousands of acres of grassland and marshes getting scorched. Similarly, Siberia and the Amazon have in recent years been making headlines for the ferocity of their wildfires, despite the former being known as a cold, barren tundra and the latter being a humid jungle, due to both locations having experienced particularly hot and dry spells in recent years. Typically, drier climates such as California and southern Europe are notorious for the severity of their wildfire seasons, with both regions oftentimes having periods during the summer, where residents constantly see smoke in the air. So, what are the impacts of these fires? Well, wildfires can be incredibly destructive, and for one simple reason: fires are hot, and heat tends to turn things to ash. In addition, wildfires will tend to latch onto literally anything that can burn, and that includes homes and other property that people may own. And that isn't just limited to people who own cabins in the woods. Under the right conditions, urban fires can and do happen, with some of the worst ones having virtually destroyed entire towns, as was the case in 2018 when a wildfire in California decimated the town of Paradise, leaving only an estimated 5% of buildings still standing. Even if a wildfire stays in a forest or desert, the effects can be devastating, as crucial habitats and other safeguards in the environment can be destroyed if a fire tears through. The effects oftentimes do not stop after a fire stops burning, too. If the charred terrain sits on a mountainside and there is heavy rainfall in the months or even years after the fire, the result can be devastating mudslides that can be just as, if not more damaging and lethal than the actual fire. However, wildfires are a naturally occurring thing with or without human intervention, and the natural burning allows for plant nutrients to return to the soil and ultimately make the ecosystem healthier when it grows back. If fires burn too frequently, however, this cycle can be offset, and the region can be vulnerable to invasive species that thrive in burn-scar ecosystems. Finally, large fires can put out plumes of smoke that are so massive they can affect air quality and cause red sunsets thousands of miles away, and even on different continents from where the fire originally happened. So, knowing how destructive wildfires can be, what does human intervention look like? Well, it's extremely complicated and depends on a number of factors, such as the size of the wildfire and the proximity to human civilization. If a wildfire is just burning in a remote part of boreal forest, nowhere near where humans are, the fire will probably just be allowed to burn, in part due to the benefits I talked about earlier. However, if the fire is burning too close for comfort, firefighters will employ a number of tactics to slow the fire. The most obvious way of doing this is by dumping a ton of water onto the fire, either by dropping the water from helicopters or pumping it through the ground. However, there is another method to slow the spread, and that's by removing fuel for the fire to burn with. One way to do this is to clear vegetation that can burn from areas surrounding the fire, so that when the fire reaches these areas, it has nowhere to go. This can be done by digging and cutting out grass and other plants, or by lighting the desired area on fire in a prescribed burn, though the latter method can obviously backfire horribly. In addition to slowing or stopping the spread of the actual fire, measures are often taken to make sure the public is safe, which usually means evacuating anyone that could be in an area that's at risk of being burned. Last but not least, progress on controlling the fire is measured by the percentage of the fire's perimeter, where firefighters have been able to stop the fire from spreading completely. If the spread has been stopped on a section of the perimeter, that part of the fire will be classified as contained, and a fire that is at 100% containment means that the fire has completely stopped spreading. Okay, with all that out of the way, how have wildfires changed in recent years? Well, unfortunately, climate change has had an especially significant impact on the frequency, location, and severity of wildfires in recent years. The main reason is because wildfires, as I stated before, are often at their worst during particularly hot and dry spells, and climate change is making those heat waves and droughts worse. But there's another, more harrowing aspect of climate change when it comes to these wildfires. They are going places that they haven't been going before. To give an example, up until 2021, it was considered near impossible for a wildfire to go over the crest of the Sierra Nevada mountains. The simple reason was because these mountains were so high and got so much precipitation during the winter that they were considered places where wildfire just couldn't burn that easily. However, in the summer of 2021, amidst one of California's worst heat waves and droughts in recent memory, not one, but two massive wildfires were able to go over the Sierra Crest and down the other side, threatening some communities, including a few in the Lake Tahoe area, that were considered largely fireproof. To make matters worse, climate change is caused by an increase in the amounts of carbon dioxide and other greenhouse gases in Earth's atmosphere. And when wildfires burn, they release many of these greenhouse gases into the atmosphere. As a result, not only are wildfires being made worse by climate change, the fact that these fires are worse is releasing more carbon dioxide, which creates a positive feedback loop. As time goes on and the Earth gets hotter, we may soon start to see the size, location, and scale of destruction of these wildfires reach levels that we have never seen before. And we need to do our absolute best to be ready for when these monsters hit, as well as limit our own carbon emissions to ensure that the scope of the damage is limited in the future. And on that extremely positive note, that's all I have to say about wildfires. As always, I'd appreciate if you would like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.